Okay, alright you guys, so hopefully everyone is doing well. So we're going to go ahead and continue our notes on the unit circle. So go ahead and set up a separate sheet of notes, or you can go ahead and continue it wherever you left off. But make sure you write down example number 4. Write that down and then we'll get started. Okay, so for A, they want us to find the sine of pi over 2. Alright, so this is just, again, this right here is just going to be a little practice for us. This is the same thing as sine of 90 degrees. Okay, so keep that in mind just because you want to be able to switch in between sine and cosine, degrees and radians right away. Okay, so you might be wondering, Mr. Rubio, how do I find that? I only know how to find sine of 30, 60, 90, and pretty much anywhere in between. Okay, so here's what you're going to do. So first, you're going to go ahead and draw your unit circle. Okay, so I know usually we draw, we've been drawing a quadrant, but you're going to get used to drawing the unit circle because you're going to be working with angles that are bigger than that. Okay, so draw your little circle, and there you go. So you know that right here, this is 1, 0, this is 0, 1, this is negative 1, 0, and then this is 0, negative 1. Okay, so that's the unit circle that you want. Okay, they want us to find sine of pi over 2. So where are my angles? So okay, you know that this angle is 0 radians, this right here is pi over 2. So they want you to find pretty much this angle right here. So I'm gonna go ahead and draw it. They want you to find this angle right here. Okay, so that's your sine of pi over 2. Your pi over 2. Okay, so a couple facts. You might be wondering, Mr. Rubio, we don't have any special right triangles. You're correct, we don't. This is a right angle right here. But here's a couple facts you do want to know. Okay, so you know you have this point right here, this point 0, 1. So it turns out that I'm gonna write 0, 1 right there. So that's the point that it's referring to right here. Okay, 0, 1. This right here, as you may know, this is obviously your x, and that's your y. But a fact that you want to know, pretty much for the rest of the unit circle, is that your x right here, this is cosine of theta, and your y is sine of theta. Okay, so therefore think about it. You have sine of theta, but what is this theta we're talking about? This is sine of pi over 2. So if this is your cosine, that's your sine, then therefore your sine of pi over 2 is going to be 1. Okay, which is equal to y. Alright, so again, sine of pi over 2 equals to 1, which equals to y. So therefore that's your value right there. Okay, it's all about looking at the coordinates, you guys. So you might wonder, Mr. Rubio, where did you get that from? Well, remember when I showed you previously in the triangle, your x is this right here, right? And then when you go up y, that's your sine. So that means that this is cosine and this is sine of theta. Okay, any questions? Alright, let's move on to B. Now let's go to B. So again, you have 3 pi over 2. So again, I'm going to go ahead and draw my unit circle. So hopefully you already noticed that 3 pi over 2 is going to be in one of the axes. So again, I'm going to go ahead and draw my circle. So draw your little circle right here. Again, label all your points. So, okay, so you know that this is 1, 0, 0, 1. And again, you might already know this. You might be wondering, Mr. Rubio, I know this, like, you don't need to keep writing it. But we want to make sure that we get this to perfection. Why? Because the unit circle is something that you got to know perfectly. You got to know every single value. Every single value. You're going to get tested on this and you want a complete quiz, so you got to know your stuff. Okay? Again, label your angles. This is 0 radians. This is pi over 2 radians. This is pi radians, and this right here is 3 pi over 2 radians. Okay, so you're pretty much looking at this angle right here. So you're looking at that angle right there. Okay, that circular thing right there. Okay, now let's go from there. So again, what's the value that we have 3 pi over 2? The value that we have is 0, negative 1. So again, we know that this is cosine. This is cosine of 3 pi over 2, and this right here is your sine of 3 pi over 2. Okay, so you have cosine and sine, right? But think about this. What is cosecant? What is the formula for cosecant? So cosecant of 3 pi over 2 is equal to Because you know that sine is y and cosecant is the reciprocal of that. So instead of it being y, it's going to be 1 over y. So that's what cosecant of 3 pi over 2 is. Let me go ahead and plug in. What's your y right here? Again, cosine of 3 pi over 2, that's your x, right? Sine of 3 pi over 2, that's your y. What's my y? Your y is negative 1. So therefore your value is 1 all over negative 1, which ends up equaling negative 1. And there you go. That's your value right there, negative 1. If you want to make this fancy, this thing right here is the same thing as 1 over sine of 3 pi over 2. So I know you can barely see it right there, but it's 1 over sine of 3 pi over 2 in case you want to keep note of that, okay? Alright, so that's that. Let's continue to C. Cosine of pi. Okay, draw again your little unit circle. Again, whenever we do these, you guys, just for your practice, make sure you draw your little circle. And remember, it's a circle of unit circle of radius 1. So again, 1 0, 0 1, negative 1 0. Memorize this like there's no tomorrow, and 0 negative 1. Okay, label your angles. 0 radians, pi over 2 radians, pi radians, and 3 pi over 2 radians. Okay, so we already know cosine of pi. What angle are we looking at? We're looking at this angle right here. Okay, so that's the angle you're looking at right there. Now, take a look at this. So again, I'm gonna write this right here, negative 1 comma 0. Again, we know that this is your x and this is your y. We know that this x is cosine of pi and your 0 is sine of pi. So again, I'm gonna go ahead and write it. Cosine of pi equals to x, which again equals to negative 1. Y así de fácil, easy. That's it. That's all you gotta do for these. You don't need any special right triangles because you don't have any special right triangles. You just gotta look at right here at your points and just figure it out from there. Y así de fácil, easy. Okay? These are one of the easier ones that you do. Alright, let's go to D. Tangent of pi over 2. Okay, draw your circle again real quick. Just real quick. So you're gonna get, as you do more practice, you can get better at this and you're gonna memorize this and you're gonna be able to do it without necessarily having to do your own graphs. So once you get to that point, you know that you're already mastering it. So that's what I want to get you guys to. Okay? But we're doing it on graphs right now just because this is something new to us and we want to make sure that we get it done as much as we can. Okay. Label your angles. 0 radians. Pi over 2 radians. Okay. That's pi over 2 radians. So that means that I'm going to be working with 0, 1. And again, label them. This is your x, this is your y. This right here is cosine of pi over 2. This right here is sine of pi over 2. Okay? And so you go from there. Now, take a look. So we're going to go back to our identities. So I already taught you guys what the identities are going to look like. So you know what, cosine equals to x, sine equals to y. But tangent here is going to be y over x. And again, you don't believe me? Look back at your notes. It's right there. That's the formula that you need. So let me go ahead and plug it in. What's my y? My y is 1. What's your x? Your x is 0. Now the answer is 0 and no, it is not. Nothing divided by 0 is 0. You gotta remember that to the T. Anything divided by 0, anything divided by 0 is undefined. So I'm gonna write just an abbreviation right there, undef. Whenever you see undef, think undefined. Alright? And that's how you do D. Alright, I'm gonna go ahead and continue. I'll pause it and then we'll continue. Okay, now go ahead and write down this definition right here of reference angles. And then go ahead and pause it, and then once you've written it down, then continue the video. Okay, so let theta be an angle in standard position. So just an angle in standard position. Its reference angle is the acute angle formed by the terminal angle and the horizontal line. Okay, so reference angle. So first let me show you a couple examples. So if you look at quadrant 1, so say you have this angle right here, theta. So say this is angle right here. Then your reference angle would be this angle right here. Why is it that angle? Because remember, by our definition, it's going to be formed by the terminal angle and the horizontal line. Okay, so that's how you do it. Okay, so it's made by the horizontal line and this right here. Now let's look at quadrant 2. Okay, so now you have this angle right here. So you might be wondering, okay, so this angle, this is your angle theta. So when you have an angle theta in quadrant 2, this is how it's going to look like, something like that. So what's my reference angle going to be? It's going to be this angle right here. So again, these two right here are reference angles. Okay. Now, for you to know your reference angles, remember it's going to be the angles formed by this terminal side right here and the horizontal line. Okay, so the terminal side and the horizontal line. That right there is your reference angle when you're looking at quadrant 2. Quadrant 3, again, you're going to have an angle that extends over here. So your reference angle, again, so reference angle, I'll just abbreviate it ref angle. It's going to be this angle right here, again, formed by this side right here and the horizontal line. So it's just this short angle right here. And then last but not least, quadrant 4, it's when an angle almost goes all the way around. It's going to be, again, this angle formed by this horizontal line and then the side right here. Okay, so that right there's your reference angle. Now you might be wondering, Mr. Rubio, what's the importance of this? Well, it turns out that, remember how previously I mentioned that we were able to find sine of, pi over 6, pi over 3, like that kind of good stuff? Now you're going to be able, because of this, you're going to be able to find the sine, the cosine, all the trig functions of angles that are bigger than 90 and even bigger. So, for example, you might have an angle of like 120. Then now you're going to be able to find it. Why? Because you're going to be able to form a triangle with this angle right here. Okay? So you're going to see more examples right now as we go through them of how you're going to use the reference angles, but a reference angle is very important for you to know. Okay? So I'm going to go ahead and continue and then we'll go. Alright, go ahead and write down example number 5. Find the reference angle of these two and then we'll continue from there. Okay, so first they want us to find angle 210. So here's what I'm going to go do. I'm going to go ahead and draw just my angle right here. Okay, so 210. So again, we're looking at degrees. So this is 0 degrees, this is 90 degrees, this is 180 degrees, and this is 270. Okay, so we're going to go ahead and draw an angle in standard position. So again, draw your first angle. So first we go, this is 90, so it's not there. This is 180, this is not there. This is 270, we already passed it, so your angle is going to be somewhere around here. Okay, and so this is your angle right there. So 210 degrees. Okay, so now we want to find the reference angle. So think about where it lands. So this terminal side right here, is it going to land the first quadrant? No. Does it land the second quadrant? No. Does it land the third quadrant? Yes. So this is quadrant 3. So this is quadrant 3 that it lands right there. And then now we can go from there. So now what is my reference angle? Your reference angle, again, you guys, is going to be this side and the horizontal line. So take a look, what angle does it form? So when you, with this side and the horizontal line, it turns out that it's this little angle right here. And so right there, that right there is your theta. Okay? So now take a look at this. So now here's what we're going to do. This angle right here, for you to find your reference angle, you have to subtract. We're going to get, okay. So you have this theta prime here. So what you're going to go ahead and do is, this is 210 degrees. What is this angle right here? This is 180. So what I'm going to do is I'm going to get my 210 degrees. And then I'm going to subtract 180. What's 210 minus 180? If you do it in your head, it's going to give you 30 degrees. And this right here is your reference angle. Okay? So this angle right here, you guys, this little theta prime is going to be 30 degrees. So you just found this little angle right there. This one right here. Okay? So again, can't emphasize it enough. This angle right here. Alright, that's the angle that you found. And that's it. Now let's go to B. So again, draw your little graph right here. And it's going to help you drawing the graphs because you're going to know where each angle lands. So this is in radians. So this is 0, pi over 2, pi, 3 pi over 2. So think about it. We know that pi over 3 is right here, right? So pi over 3 is there. That's not it. 2 pi over 3 is somewhere over here. No, that's not it. 3 pi over 3, that's the same thing as pi, so it's right here. So it has to be a little bit over here. So therefore, here we have our angle right here. Again, draw a little angle right there, and that's right there 4 pi over 3. Okay, so we were just like, drawing it the way it is. And you know that that's 4 pi over 3 because this is 3 pi over 3 here, right here. Okay. Now we go from there. So again, you want to find, because we know this is in quadrant 3, we want to find this angle right here. You want to find theta prime. Okay. So then we get our angles. So we get about let's see. So you get 4 pi over 3 minus, which is this angle right here, minus pi. And then you go from there. So you got to convert it, right, to this one right here. So therefore you have to get 4 pi over 3 minus 3 pi over 3. And you know that 4 pi over 3 minus 3 pi over 3 will give you pi over 3. And therefore, that right there is the answer as desired. Okay? Now, what does this mean for us to be able to find the reference angle? That means that, like, for these angles, you have to subtract 180. Okay? And that's it. That's all you have to do. Alright, go ahead and finish writing this down and then continue to write down the next problem. Okay. Go ahead and draw example number 6, you guys. So, finding the trig values. So, these 4 problems. Once you've done that, we'll continue from there. And then, once you've written it down, then continue the video. Okay. So first, let's find sine of pi over 6. 5 pi over 6. So here's what you're gonna do. You're gonna draw yourself a little coordinate plane. I'm gonna draw the angle. So label your angles. You know this is 0 radians, pi over 2 radians, pi radians, and 3 pi over 2 radians. Okay. So we know that it's 5 pi over 6. So I'm gonna change this to the denominator of 6. So it's gonna be 3 pi over 6, and this will be 6 pi over 6. But now take a look at this. 5 pi over 6 is obviously between 3 pi over 6 and 6 pi over 6. So therefore I have to go 4 pi over 6, 5 pi over 6, and then 6 pi over 6. So you know that your 5 pi over 6 is going to be somewhere over here. Okay? So this is 5 pi over 6. Again, you have your angle right there. And that's that. Now, here's what you're going to do now. You're going to go ahead and find the reference angle. So I'm going to find my reference angle, which is this angle right here. Okay? Why is that my reference angle? Because your reference angle is always the angle that is made with the terminal side and the horizontal line. So this right here is your reference angle. Now, I'm going to go ahead and find my reference angle. So for me to get from 5 pi over 6 to 6 pi over 6, we just need to add pi over 6. So this angle right here is pi over 6. Now you might be wondering, Mr. Rubio, what are we trying to get at? So the beautiful thing about this is that when you find trig values that are bigger than 90, you're going to need that reference angle. Why? Because that reference angle itself is going to make you a triangle. So you're going to make a triangle, and there you go. Okay. Now we do have a unit circle, right? So we're gonna look at a unit circle. So remember, unit circle is a radius of 1. So I could go ahead and just do like a unit circle right here. You know that this is 1 0 0 1, and you get the deal. All the radiuses are 1. So therefore, your side right here must be 1. So now here's the catch. For every triangle that you make right here, guys, you're gonna have a radius of 1. So now we can go ahead and find the sides. This is pi over 6 or 30 degrees. So therefore, this is half of 1, so it should be 1/2. This side right here is going to be square root of 3 all over 2. Okay? And you might think, okay, so we found our triangle. Good. There's one little thing that you gotta be very, very careful with. Take a look at these sides. A hypotenuse, we know it's positive, so that's good. But what about this right here? Is this positive? Was it above the x-axis? Yeah, so it is positive. But take a look at this side right here. Is this positive? Whoa, it's on the left side of the y-axis, and we know that things at the left side of the y-axis tend to be negative. So therefore, this right here is negative right there. Be very careful. that's a negative. And then now we get to find our sine. So sine of 5 pi over 6, we know that that's the same thing as y all over 1. What's y over 1? That gives you y over 1 is the opposite side all over the hypotenuse. So therefore your answer is 1/2 all over 1, which ends up being 1/2. And that's your answer to that trig value. And that's it. Okay? So again, draw your angle, find your reference angle. Once you have the reference angle, make a triangle with a hypotenuse of 1. Once you have that, find all the sides using this angle right here. And then from there you can find your sine just using the reference angle. Okay? And that's how you're going to find the trig values. Let's go to B. Make your table again. Sorry, not your table, your graph. Now let's graph it. Again, label this 0, pi over 2, pi, 3 pi over 2. We have a denominator of 4, so I'm going to change that to a 4. So pi over 2, you know, is the same thing as 2 pi over 4. You know, this is the same thing as 4 pi over 4. And, you know, this is the same thing as 6 pi over 4. Okay. 5 pi over 4 is in between 0 and pi over 2? Nope. Is it in between pi over 2 and pi? Nope. Is it in between 4 pi over 4 and 6 pi over 4? Yes, of course. It's right here in the middle. Okay? So we have an angle right there. That is 5 pi over 4. Now, take a look at what quadrant you're in. You're in quadrant 3, right? When you have a reference angle, remember your reference angle, because you need to find that. Your reference angle is the angle between the terminal side and the horizontal side. So therefore, you want to find this angle right here. Okay? That's the angle you want to find. Now take a look at it. This again, I'll just label this right here, 5 pi over 4 and 4 pi over 4. To get from here to here, how much do I need to add? You need to add pi over 4. So this right here is pi over 4. And now you can make your little beautiful triangle. Again, we're looking at a unit circle. So therefore, the hypotenuse right here is 1. Oh, what do we know about the sides of a triangle with pi over 4? You know that the opposite side is square root of 2 over 2. And this is square root of 2 over 2. Now you might be thinking, there we go, we have the triangle. But, what did I just say? I said, be careful with the signs. This side right here is on the other side of the y-axis. So is this positive or negative? Negative. Why? Because it's on the other side of the y-axis. It's on the left side. What about this right here? Square root of 2 over 2. Is it on above the y-axis, above the x-axis, or below it? It is below it. So therefore, when it's below, it's negative. And there you go. These are your sides, negative square root of 2 and negative square root of 2. Now we get to find cosine of 5 pi over 4. What does that equal? That's x over 1. What is your x? Your x is this adjacent side. So it's negative square root of 2 over 2 all over your hypotenuse, which is 1, So therefore your answer is negative square root of 2 all over 2. Y ahí estás. Sorry about that, I didn't mean to. Should have put that side right there, but there you go. There's the work. Okay? And that's it. That's all you gotta do. So once you've written down my work right here, you guys, go ahead and pause it. And then once you go from there, we'll go to C and D. Okay. Let's go to C and D. So now, tangent of 4 pi over 3. Again, make your axis. Label it by radians. 0, pi over 2, pi, 3 pi over 2. Hopefully you get the hang of this already. Okay. Again, we're looking at over 3. So you know that this is 3 pi over 3. And you could kind of go from there. So, if we did 3 pi over 3, we could divide this into thirds. So this would be 2 pi over 3. This would be 1 pi over 3. Over 3 pi over 3. So we need to add one more third. So your 4 pi over 3 should be somewhere about here. It'll be somewhere right there. That's where 4 pi over 3 is. Okay. Now again, take a look at this. For you to find your triangle, you need to find your reference angle. So how much did it take for me to get from here to here? It took you pi over 3, right? So now we could go ahead and just make this triangle right here. And again, your side right here, your hypotenuse is 1. Now we go from there. This is pi over 3, right? So this is 60. So the opposite of 60, guys, is going to be square root of 3 all over 2. The side right here is going to be 1/2. Okay? This all comes from your special right triangles. Again, you need to know your special right triangles to be able to move on. Okay? And now we can move on. So now, well, before we move on, take a look at this. You have square root of 3 over 2 and 1/2. So are these positives or negatives? Well, this is on the left of the y-axis, so there should be negative right there. This is on below the x-axis, so there should be negative right there. Okay, so don't forget those negatives. It's easy to forget them. Okay? Now from there, let's find tangent of 4 pi over 3. Again, according to your formulas, that's y over x. So what's my y in this case? My y is negative square root of 3 over 2 all over your x, which is negative 1/2. And so if you do your math, you get negative square root of 3 over 2 divided by negative 1/2, right? Again, you flip it, so you get negative square root of 3 over 2 times negative 2 over 1. So this cancels, that cancels, and so now you get negative square root of 3 times negative 1, and hopefully you can see that negative times negative gives you positive, so you get square root of 3. And that's it. That's your answer, square root of 3. Okay? So remember, it's just a process, but once you get it, you get it. Okay. Let's move on to D. So cosecant of 5 pi over 3. Again, I'm going to go ahead and draw my graph. So 0, pi over 2, pi, 3 pi over 2. Okay, we can kind of look at this one from previously. So you know that 4 pi over 3 was right here. So if I add another pi, you should be about right here. So this right here is 5 pi over 3. And so your angle is right there. But your reference angle, remember, it's the angle that's right in between this side and that side. So it should be this angle right here. Now, if I want to take a look at this, you know that this right here was 3 pi over 3. So to get to right here, this is 6 pi over 3, which is 2 pi, right? So for me to get from 5 pi over 3 to 6 pi over 3, this should be pi over 3. And now we can make our little triangle again. Again, hypotenuse, since we're looking at unit circles, this should always be 1. Your pi over 3, again, the opposite of pi over 3 should be square root of 3 over 2. And then this side right here should be 1/2. Okay, so remember, pi over 3, the opposite is square root of 3 over 2. If it's pi over 6, the opposite is 1/2. But now take a look at this. This right here is below the x-axis, so it should be negative. So negative square root of 3 over 2. What about 1/2? Is this positive or negative? Well, this is on the opposite side of the y-axis, so that should be positive. Or yeah, it should be positive. So this right here is positive. Okay. So now, your cosecant, so I'm going to go ahead and write this down right here. Your cosecant of 5 pi over 3 is going to give you this. It's going to be 1 over y, right? Because it's the opposite of sine. So therefore it's going to be 1 all over, what's your y right here? Your y is this right here. So it's negative square root of 3 over 2. And then, move this up. You know that this is the same thing as 1 divided by negative square root of 3 over 2. Again, you do the reciprocal. So again, scroll this up right here. And it should give you 1 times negative 2 all over square root of 3. But since we really do this like, you know, square roots at the bottom, you get negative 2 all over square root of 3. You multiply the square root of 3 all over the square root of 3 to both of them. and then by the conjugate, remember, as we've done a lot, and your answer should give you -2 square root of 3 all over 3. And there you go. That right there ends up being your answer. Okay? So that's it. So it's a process, you know, that's a lot of steps, but if you take each step very, like, you know, closely, and you're very careful about your negatives and everything, then you'll get it. Okay? With that being said, you guys, go ahead and continue. So work on your homework assignment. If you have any questions, as always, feel free to message me or send me a question that you want me to you know, help you with directly, or anything, and I'll be happy to do it. With that being said, have a great day. Let me know if you have questions, and have a great night.